Hi everyone, it's Jazz. Welcome back to my channel, Jazzy Maths. Today we're going to look at subgraphs and degrees of vertices in graph theory. So we'll start off with a definition of subgraphs. So a subgraph is, say we take a graph H, it has a subset of vertices of G and a subcollection of edges of G. So when we write this out, this would be H is a subgraph of G. We'll do an example further down to demonstrate this. And a spanning subgraph, very similar to a subgraph, but this spanning subgraph contains all the vertices of G. So you denote it as H is a spanning subgraph of G. Okay, so we'll do some examples just down here. So we'll start off with a subgraph. So let's say if we take this kind of shape here, say this shape, this graph H is a subgraph of this shape here, this graph here even, which is G. Similarly, if we did a spanning subgraph, so I'm just gonna make this look, just gonna take these out here just so that they can fit everything in. Spanning subgraph. Again, we'll take the same kind of shape. So let's say we've got a graph like this. This is H, is a spanning subgraph of, again, the same shape, G. So the reason why this is a subgraph, this one here is a subgraph and this one is a spanning subgraph, is because this, if we look at the definition, this is a subgraph because it contains a selection or subset of the vertices V1, V2, V3 as a graph G, and it contains a subcollection of the edges E1, E2 of G. Whereas this spanning subgraph contains all the vertices of G, so V1, V2, V3, V4, and it contains a sub-collection of the edges, so E1, E2, that would be E3, and this would be E4 if we look at this graph here. E2, E3, E4. Okay? So now we'll move on to indices, neighborhoods and degrees. So an indice has two vertices that go into one edge. So this we've seen before in the previous video. So if we take an edge E equals a subset of V1, V2, then these two are indices to each other because the edge would be that and they'd be adjacent to each other. A neighborhood is a neighborhood of vertices. V1, say, is a set N, which denotes neighborhood. V1 is the vertices that we're talking about. Is the set V1 where V1 is adjacent to V2. So again, this would look a bit like this. A degree of a vertex is the number of edges that span from it. So we'll do an example further down to show this. It's denoted as a row and then the vertice that we're talking in question, and it is the neighborhood set. So if we're looking at an overall graph, this is where we use these denoted terms. So delta, small delta is the minimum degree, and a large delta is the maximum degree. So we'll do an example down here. So let's see. We'll do 5 vertices. Let's write them. What? V1, V2, V3, V4, V5. So put in some edges. It's not very clear. In fact, let's remove that one for this argument's sake. Okay. So we'll write out the degrees for each vertex. So V1, so the neighborhood, so let's say the neighborhood for V1 is only one going out of V1 is V3. So this just means that V1 and V3 are connected by this edge here. The degree of V1 is equal to 1. I'm going to write this up here just so that I can save on space. Let's have a look at, so you can just follow this pattern, like V3, you can see that it has a degree of 2, because there's 2 edges coming out of it, and the neighborhood set would be V1 and V4, because these are the ones that are adjacent to, these are the ones that you could walk to if you were walking along this path. So let's look at V4. So the neighborhood of V4, this has you can get to V3 and V5 on it. And though you can get to V5 twice, you don't need to write it in twice for the neighborhood. The degree of V4, so there are 3 edges coming out of it, so the degree is 3. So if we look at V2, the neighborhood is the empty set because there's nothing that's connected to it, and the degree is also 0. So let's look at the maximum and the minimum degree. So the minimum degree is 0, and this is of V2, and the maximum degree, delta, is, we have 2 here, 3 here, 2, 1, 0. So the maximum degree is 3 on V4. And that's it. So we've covered spanning graphs, subgraphs, indices, neighborhoods, and degrees. Is there anything that you are particularly struggling with in graph theory? Then write a note in the comments and I will do my best to accommodate and make a video for you. Until next time, bye!